All right, so after all those lessons with working with exponents and logarithms and their properties and solving equations, today we're going to look at some applications of exponential and logarithmic functions. And one area that is common that we use this in real life is when we calculate interest. Back in Algebra 1, we learned a formula called the simple interest formula, and that's where we learned that to find interest, we multiply the principal times the rate times the time, and we were able to calculate the interest. Or knowing the interest, and two of these three other things, we were able to calculate either the principal or the time or the rate in certain conditions. All right, so when I'm working with simple interest, usually my time is in 1 year. So we calculate only one time during the year. And there's some vocabulary here that we should know. And if I'm working with interest or finding interest annually, that just means one time per year. But if I'm working with an investment and it's going to calculate the interest semi-annually, that means 2 times per year. Quarterly is 4 times per year. Monthly, there's 12 months in a year, so if interest is calculated monthly, we would do 12 times in a year, and calculating daily interest would be 365 days in a year, and that's times per year. Okay, so per year. So in this first example, it says that a credit union pays interest of 8% per annum. That means per year, annual. And it says it's compounded quarterly on a certain savings plan. So if we invest $1,000 and we deposited that into the plan, and the interest is left to accumulate. That means you don't take the interest out, you keep it in the account, and then you start earning interest upon interest. All right, and we want to find out how much is in the account after 1 year. All right, so I'm going to think of this in terms of interest equals rate times, interest equals principal times rate times time. And in this, my information I have is that my rate is 8%, and I always write my rate as a decimal when I put it into the equation. So 8% means 8/100. That's 0.08. It's compounded quarterly. All right, so we're going to deal with that in a second. We deposit $1,000, so that's going to be my principal. And let's see, we want to go for 1 year. So to start with, I'm going to have $1,000 in my account. Okay. And then I'm going to use my I equals P times R times T formula, and I'm going to put these in here to find out how much I'm going to get after quarter one. How much will be in my account? So if my quarter one, this is 1/4 of the year, so I'm going to only calculate that my time is going to be 1/4. So I'm going to find out how much interest I have if I start with $1,000, and I'm going to multiply that by 0.08, and my time is 0.25. Now when I calculate this, I am going to get 1,000 times 0.08, that's $80, and a quarter of that, a quarter of 80 is 20. So I can just do this part, mental math. So my interest is $20, so after quarter one, I'm going to have $1,020 in my account. So then for quarter two, I'm going to start with $1,020. I'm going to multiply it by 0.08 and then by a quarter of a year. So my principal, I added my interest in here, so now I have 1,020 times my rate times my time, and when I calculate that, I have $20.40. 40 cents. So now I'm going to add that to my previous principal, and that would give me $1,040.40. So for quarter three, I'm going to start with my previous principal, $1,040.40, multiply that by 0.08, then by a quarter of a year, so 0.25, and that would give me $20.81. And I'll add that to my previous principal, and now I have $1,061.21. And then to find out after the fourth quarter, that would be after a full year, I'm going to find out how much interest I'm going to make on this quarter. So I'm going to start with 1,061.21 multiplied by 0.08 and then by a quarter year, and that would give me $21.22. So if I add that, 21, 22, I'm going to get $1,082.43. All right, so after a whole year, I'm going to have $1,082.43. All right, so instead of doing these calculations every one quarter of a year, or what if it was every day? We don't want to have to do 365 calculations over a year. So we have this new formula that's called the compound interest formula. So A is the amount in the account, and to find that amount, we're going to start with our principal, and we're going to multiply that by 1 plus the rate divided by the number of times we're going to calculate the interest. And then I'm going to have an exponent here, and my exponent is NT. That's a little small. But I'm going to divide by the number of times that it's calculated. So if it's calculated quarterly, I divide that rate by 4, and then it's to the power of 4 times however many years. All right, so on the next page, let's look at this up here. And I just wrote this equation up at the top again so we can refer to that. But in example 2, it says we're going to invest $1,000 at an annual rate of 10%, compounded annually, and then we're going to do it semi-annually, quarterly, monthly, and daily. And we're going to look at those amounts after 1 year and see what the difference is in the different number of times that we calculate that interest over the year. All right, so if I put in the important parts here. So I know that my principal is $1,000. My rate is 10%, which is 0.1. And then if this is compounded annually, my n is going to be 1. And I just kind of made a list here. If I calculate semi-annually, my n, the number of times I calculate it, is twice per year. Quarterly is 4 times a year. These are the same numbers I had on the other page. All right, so really what's happening is to find that amount, I'm going to start with $1,000, and I'm going to multiply that by 1 plus my rate is 0.10 over n to the n times, and we're just doing this for 1 year, so n times 1 is just n. So in my calculations here, the only thing that I'm going to change in my calculations is how many times am I calculating the interest during the year. All right, so if I'm calculating this annually during the year, and I'm going to put my calculator here, hopefully we can see this okay. So I have 1,000 times 1 plus 0.1 divided by 1, because n is 1 time for annually, and then to the first power is going to stay the same, and I get $1,100. So if I just do it 1 time at the end of the year, the amount of money in the account is $1,100. Now, if I calculate semi-annually, I'm going to have $1,000 times 1 plus 0.1 divided by 2, because it's 2 times during the year, and then that's to the second power. And I wonder if I can see better here. And when I calculate that, I got an error. So what happened? Oh, I forgot my parentheses. So this is 1,000 times 1 plus 0.1 divided by 2, close the parentheses, to the second power, enter. There we go. I have $1,102.50. So this is $1,102.50. So just by calculating at 6 months and then at the end of the year, I added $2.50 to my account. Okay, so I didn't put in any more money. This is actually money that's made on the interest. Okay, so now let's try quarterly. So if I'm doing quarterly, I'm going to do 1,000 times 1 plus 0.10 divided by 4 for quarterly, and that's to the 4th power. So that'd be $1,103.81. Okay, so again, the more times I calculate the interest during the year, the more money I'm going to end up with in my account. So for monthly, if I do 1,000, 1 plus 0.10 divided by, this time I'm dividing by 12 and to the 12th power, 1104.71. And I just did the 365 just kind of on my own. I have 1105.16. Okay, so the more times, and this is all money, so I'm just writing dollar signs there. So the more times I do those calculations, my exponent gets higher, and that's where I'm getting an increase. So if I just calculate 1 time during the year, my interest is $100. But if I calculate it every day, my interest would be $105.16 at the end of the year. All right, so I mean, we could keep breaking this time down, so I could calculate every 12 hours, where this would just be twice this amount, 730, I think that would be. But eventually what we get into is something that's called continuously compounding. Okay, so that means money is constantly going from doing the calculations, and they're putting the interest back into the account. So we call this continuously compounding interest. And the formula for that is the amount in the account is the principal, and now we're going to use our value for E. Now remember, E is just the number 2.71 blah blah blah, and then this is to the RT power. All right, so let's do some calculations with that. So it says that the amount A, that's what we want to find here. We want to find the amount that results from investing that same principal from above. So we have $1,000 and my rate is 10%, and this time I'm compounding continuously for my time of 1 year. So to find that amount, I'm going to start with $1,000. I'm going to multiply that by E to my rate, which is 0.1, times the time, which is 1. And here, if I calculate 1,000 times E to the power, so if you're using a TI-84 or 84 series, E to the E to the power is here. My exponent is 0.1 times 1, so that's just to the 0.1 power, and equals. So if I compound continuously, I'm going to have 1105.17. Okay, so I just kind of want to show you that compounding continuously is very close to a daily compounding value. Okay, so it's just a penny away for this amount of money. Now, if we're talking $100,000 or $1 million, there would be a greater difference here. Okay, but for a modest amount of money, you know, you have a generous grandma that gives you $1,000 to invest, and you put it into account with these conditions. If it's in an account that's compounding continuously, that's like every day they're putting interest in there, and you're getting interest on that interest. Okay, so this, I just want to make a note, is close to compounding daily. All right, so then just here's this chart down here, and this is called an effective rate of return. So a lot of times credit cards will do that, and you'll see that they'll say they have a 3% interest, and then they'll have a little asterisk, and then it'll say, well, actually it's 3.15% or 3.2%. But the annual rate that they use is a specific percent, and that's what they'll advertise. But here, this will show the difference depending on how many times you calculate that interest. So if you're going to calculate it only one time during the year, that's your effective rate of interest. But most calculator companies will do this monthly, and you're actually paying almost 0.5% more in interest than they advertise. All right, so this is depending on how is it compounded. Okay, so if they do the compounding more than one time during the year, you're going to have more than 10%. Okay, so annual is 10%, but anything else, we're going to add more money to that. All right, so the next one is asking us, organize here. This is asking us to compute the effective rate of interest. So here's a scenario. On January 2nd, 2007, you put $2,000 into an IRA, which is an individual retirement account. It's an investment. And they're going to pay you interest of 7% per annum year, compounded continuously. So when I think of compounded continuously, I always want to write that formula down. A equals P times E to the RT power. The first part says, what will the IRA be worth on January 1st in 2027? Well, if I'm putting it in 2007 and I'm looking at it in 2027, if I subtract this is 20 years. Okay, right? How much will it be worth in 20 years? So in part A, I'm going to use my A equals P times E to the RT power. A is the amount that's in the account. My principal was $2,000. That's how much I invested. I'm going to multiply that by E to the R, which is 7% or 0.07, times T. In this case, it's 20 years. And after doing those calculations, 2,000 times E to the point, and I can actually, I'm going to do this here so I can show you. I have 2,000, and then I'm going to do times E. I can do the calculation right in the exponent. So I have 0.07 times 20, and whoops, and that value just stayed in the exponent. If I want to get my cursor out of the exponent, I have to use the arrow, and then it'll drop down. But when I do that calculation, I get $8,110, and we always round to the nearest cent, so that'd be 40 cents. So the amount after 20 years is $8,110.40. All right, so that's a pretty good investment right there. You start with 2,000, you go to 8,000. So part B is asking us the effective annual rate of interest. All right, so if I'm compounding continuously, I want to find out how much interest that'd be. So the amount in my account, if I'm compounding continuously, would be $2,000 times E to the R, which is 0.07. And I just want to do this for 1 year, the annual rate of interest. So for 1 year, I'm going to just leave this. So I'm going to multiply by 2,000 times E to the 0.07. And I get 2145.17. Now I started with $2,000 and I ended up with $2,145. So my interest actually is only $145.17. Now, if I were to use my simple interest formula for this, we would find the effective annual rate. So remember that simple interest is I equals P, principal times rate times time. I know my interest was 145.17. My principal was $2,000. My rate was 0.07. Oh wait, I'm finding my rate, sorry. And my time is 1 year. So basically, to solve for rate, I have to take 145 and divide it by 2,000. And that'd get R by itself. And when I divide 145 divided by 2,000, I get 0.0725, which is 7.25%. Okay, so this is one of those things that if I'm compounding my interest continuously at a rate of 7%, if I do the simple interest formula, it's really 7.25%, which if I'm investing money, that would be good. But if I'm borrowing money and I have to pay back that interest, that's not so good. All right, next part is what's called the present value formula. And remember, we started off with A equals P times 1 plus R divided by N to the NT power. So to find the amount, principal, rate, number of times compounding, and the time. So let's say we know we have an amount and we want to know what that would have started off with. So basically we're solving for P. Now, if I were to solve this equation for P, I would divide by all of this. So I would have A over 1 plus R over N to the NT. But to get this out of the denominator and move it up, I just have to make my exponent negative. So if I'm solving for P, I have A, everything in the parentheses is the same, but my exponent is negative, just so I can move all of this up here. All right, so same thing, and this is if it's compounded a number of times per year. Same thing if it's compounded continuously. Remember, I had A equals P times E to the RT, and if I divide by RT, E to the RT power, I get P. Well, that's the same thing as saying P equals A with all of this on the denominator, right? Because I could put that on the denominator, it would equal the same thing. So it's just another way to write that. In example 5, we have a 0 coupon, and that's a bond, and it can be redeemed in 10 years for $1,000. So this is the amount it's going to be after my time is 10 years. Okay. How much should we be willing to pay for it now? So we're finding the principal, so we're going to use this formula for P. How much should we pay for it now if we want a return of 8% compounded monthly? And then another example would be 7% compounded continuously. So for part A, I'm going to use, this is compounded monthly, and that means my N is going to equal 12. So I have the amount I want to pay for that bond. In 10 years, it's going to be $1,000. So I have $1,000 for A. I'm going to multiply that by 1 plus my R is my rate, which is 0.08, and it's compounding monthly, so divided by 12, and this is to the N and T. What's my T? 10 years, sorry, I couldn't remember what that was. All right, so we have this calculation to do. I can put that in my calculator. So I can type it in the calculator just exactly as I see it here. And when I do that, that p-value is going to be $450.52. So that means if I invest $450.52 in 10 years at an interest rate of 8% compounded monthly, I'll have $1,000. So in part B, I'm going to now pretty much have the same thing. My rate's changing to 7% and I'm compounding continuously. So I'm going to use this formula. So my P equals A times e to the RT, but that's negative RT. So I want to know how much am I going to pay, how much am I going to pay if the amount in 10 years is $1,000 to the negative R is 0.08. Nope, it's 0.07 in this one, and that's multiplied by 10. So 1,000 times e to the negative 0.7 basically, and on the calculator that would be $496.58. Okay, so we are almost done. The next one, I think I'm going to leave doubling and tripling an investment to do in class. So we'll finish this up when we get into class.